Alright guys, this is the big day in 8-4 Factoring by Frowny Face Factoring. Please don't let all of these steps overwhelm you. It's really not as bad as it looks. And I'm not even going to go through those steps because I just got to talk myself through each one of these processes. I'm going to talk through those 8 steps. But these are here for when you need to look back of what did I do in this step. I typed it all out for us. So what is Frowny Face Factoring and when to do it? It's just like easy factoring, but very different because the A value will not be 1 in this case. So here's what we got. We got to make sure this guy is ready to run. That's got to be equal 0. And you can go through the whole factoring cheat sheet of is there a GCF? That answer is no. Is this a difference of squares? No way, because it's 3 terms. Is it a perfect square trinomial? Nope, that's not even a perfect square. Can I easy factor it? No, I cannot, because that number right there needs to be a 1 and it is a 2. So we got to have them ready to run. And then here's one reason that I call it Frowny Face Factoring. I would literally like you to draw this, that's wrong, this little frowny face right here. And the idea is you've got to take A times C in this case. So when I do that, 2 times 6 is 12. We are going to put that there. That's one reason I made up the term Frowny Face Factoring for this guy. The other reason is because it's not that fun to do because it's a lot of steps. So here's what we've done. We've got it equal to 0, and we've multiplied those together. Now here's our job. We need to find 2 numbers that multiply together to be 12, but at the same time add together to be 13. So those 2 numbers, they're both going to be positive, are 1 and 12. I would like us to write those 2 numbers off to the side. So the only difference here is we had to multiply these together first to get that 12, right? So that's weird. Then what we'll do is we got those guys. We're going to write this equation all over again as 4 terms. We're going to break this dude up. He is 3. We're going to do it into 4 terms, and here's how I talk it through. Your leadoff man starts off. This is that 2x squared. You're going to start off with 2x squared. He's still your leadoff man. But then these next 2 guys that we just found, the 1 and the 12, they will come next. It is a positive 1, but we need to put an x with it, and a positive 12. We're going to take those 2 numbers that we found and put an x with them. And then this guy right here, I call him the caboose, right? He's going to come last. Because in a train, the caboose is the last car in the train. And don't forget, you need the equals 0 part. So we took these 3 guys and made them 4 guys by taking this 13x. We just like split that up. That 13x is totally 1x plus 12x. So that's that step. The next move is step 5. We are going to double group. And what I mean by that is we're going to make the first 2 terms, put them into a parenthesis, and then the next 2 terms, we're going to put those in parentheses. You see there's a plus in the middle, though, so it's not like we're multiplying them together. We just double group those guys. So that's step 5. Step 6 is take the GCF out of each group. So I'm going to color them. I got an orange group right here, and I got a pink group right there. I'm going to just go 1 group at a time and look at the orange guy. Let's take out the GCF. Between a 2 and a 1, there is no number that I can take out, but each of those have an x with them, so I'm going to factor out an x as the smallest amount that I see, and see what's left over in those parentheses. I'm going to put in green. So 2 divided by 1 is 2, and there's going to be an x with it still, plus isn't 1 divided by 1, 1, and those x's kind of divide out to be 1. You see, if I was to redistribute that x through the parentheses, I would get back what is above me. So I took the GCF out of that group, and now I got to do it again for this pink guy. There is one small little trick. Whatever the sign is right here, do you see that was a plus? I'm going to highlight him in green. Whatever the sign of that 3rd term is right there, that's the sign of the GCF you got to take out. So I got to take out a plus. And now between a 12 and a 6, would you believe I can take out a 6? This guy has an x with it, but that guy does not have an x with it. So I'm going to erase this and put it in blue for a second because of what I want to do with that. So sorry about that. But now let's do the factoring out. So what's left is 12x divided by 6 is 12 divided by 6 is 2. there was an x with it, and then plus 6 divided by 6 is 1 in that case. And would you agree that I still have the equal 0 there, that here's the interesting thing. I know this is weird because it's our first example, but this and this are the same. And that's supposed to happen. Every time that's supposed to happen. They might not be 2x plus 1, but what's inside those parentheses will be the same. So we have done step 6, take the GCF out of each group. Now here's the weird maneuver. We are going to truthfully, each one of these two terms that I put a blue box around has a 2x plus 1 with it, right? So we are going to factor those out. And here's the shortcut for it. I call it regroup. We're going to take the GCFs and make them a group of their own. You see, they're both in blue. X was the GCF I took out of this group. 6 was the GCF I took out of those. And then this guy right here, I call him the common group. He's going to come down for the ride. And the equal 0 is still there. So this is the factored version of that guy right there. We factored that by Frowny Face Factoring. If I was to multiply this out, I would get 2x squared plus 1x plus 12x plus 6 back, and that simplifies to be this guy. But see, we're still not done because this is an equation. They want us to solve with the 0 product property. So what value of x makes that 0? If x is negative 6. Or what value of x makes this group 0? That's back to that trick we talked about a couple of days ago, the opposite of this guy over that guy, so negative 1 over 6. There's the answer to those two, to that quadratic is x could be negative 6 or x could be negative 1/6. Wow. Holy cow, that was a lot. You cannot get good at this in just one try, so we've got to try that again. So I'm going to save you a lot of boredom right here on this video, trying to go a little quicker. I need to Frowny Face factor this because the a value is not 1, right? That is a 3. But before we do it, it's got to be equal to 0, which it is. So what's our first move after we get it equal to 0? Boom, make the Frowny Face and be very careful. We have to multiply those two numbers together. It is not a 3 times a 5, it's a 3 times a negative 5, which is a negative 15. So my job now is to find two numbers that multiply together to be negative 15. So would you believe one of those guys is negative, but they add together to be 2. So that would be a 3 and a 5, and if the 3 was negative. I do want you to put those two numbers right here. That helps me grade these guys. So I have done the Frowny Face thing, and I found my two numbers. Now for the easy part. Once you do this a few times, it gets easier. We're going to split this guy up into 4 terms. Leadoff man starts us off. Then the two numbers that we just found right here, I want to put next with the letter next to it. In this case, the letter is M. And here's some advice. If there's a negative guy, start with him and put the positive guy second. That will make sense later. So got my leadoff man, got my two numbers with an M next to them, and then I need my caboose of a -5, and that's going to equal 0. So, wow, we took him from 3 terms to 4 terms. The idea next, double group. The first two guys go in a group, the second two guys go in a group, so we can take the GCF out of each group. So we'll start with the front boy right here. Each one of those has a factor of 3 with them, so I can take out a 3. Each one of those has an M with them, and M to the first is the smallest, so he's coming out, and now I will undistribute. So that would be M minus 1. And now, since we've done this once already, since I got M minus 1 right there, I better get it again the second time when I do it. Here's the weird trick. Whatever the sign of that guy is, that's the sign of the GCF I have to take out. So I have to take out a positive. Each one of those has a 5 with them, so I'm going to take out a 5. This has an M, but that does not have an M with it, so I cannot factor out any M's. So then I'm just stuck. I need to divide, and I will get M. That's going to be a minus, and 5 divided by 5 is 1, and hooray, I got the same group back both times. That's supposed to happen. Then the next move is to regroup them. The GCFs become a group of their own, so those are my green guys right here, 3m plus 5, and then the common group comes down for the ride, and that would equal 0 in that case. And then we could solve with the zero product property. M could equal opposite of this guy over that guy, negative 5/3, or 1. So weird, so crazy. 8 steps. It's not really like 8 lines of information, but there's 8 little things we got to go through. Let's get better at it by doing another one. This is not easy factorable because that number in front of r squared is not a 1. This bad boy is totally equal to 0, so he is ready to run. So our job is to frowny face factor it. So make the frowny face, and I got a 14 there. You are multiplying the 7 times the 2. And here's our job. Find two numbers that multiply together to be 14, but add together to be a negative 15. So since they have to multiply together to be a positive, both the signs are the same, and that's going to be like 1 and 14, but they both have to be negative since they have to add together to be a negative 15. So there's my two numbers. So I found my two numbers. Now I split them up into 4 terms. Leadoff man. Then I'm going to put these next two guys. It doesn't matter what order you put them in. It does help if you can make the third guy positive, but that is impossible since they're both negative. So we'll see how that affects us. And then the caboose comes last, and of course it's equal to 0. So leadoff man, the two numbers with an R next to them, caboose equals 0. Next move, double group. And then here's the weird part. The first one's still the same. We got to take the GCF out of each group. So 7 and 1, it's just a 1, but both of them have an R with them. So I'm going to factor out an R. That would be 7R minus 1. I better get that back again, but here it is. Here's why we'd love if that third guy was positive. He's not, bro. He's a negative. So what I got to do is factor out a negative GCF to make this work, right? So factoring out a negative GCF between these bad boys, you just look at it and say, okay, like 2 is the GCF in that case, but you need to have the minus in front of him. Then we factor that out, and we'd get a 7R minus 1 again. And look, if I was to distribute, that would be minus 14R, and that would be a positive 2. So a quick little double check there. Weird. Still got to have the equals 0. Then we have done that. We factored out the GCF from each group. Now it's time to double group. The GCFs become a group of their own. That's the purple guys. And then the common group comes down for the ride. It's still equal to 0. And now, zero product property. R could equal 2, because that would make that 0. Or R could equal opposite of this guy over that guy, 1/7. All right, there's 3 down. Just a few more to go, but we still need more practice. I just know it's still weird. We're going to get better. So got him ready to run. Got a frowny face because the A value is not 1 in that case. So time to do the frowny face thing. Boom. 12 right there. Don't those two numbers multiply together to be a 12. They also need to add together to be an 8. So two numbers that multiply together to be 12 and add together to be 8 are 2 and 6. So now let's split them up into 4 terms. Leadoff man, 3x squared. Then my two guys with an x next to them, doesn't matter what order they go in. I like that third guy to be positive. He is positive if possible. Sometimes that's not possible. Then caboose equals 0. Double group. Boom, 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 boom. So take the GCF out of each group. 3 and 2, nothing but 1. X squared and x, taking out an x. So that would leave me with 3x plus 2. And then this is a positive guy, so I'm going to take out a positive GCF. I better get me a 3x plus 2 back. When the inside, what's my GCF I can take out of there? Looks like 2 goes into each one of those guys. So what's left? You know it, 3x plus 2. Don't forget the equals 0. And then the next move, regroup. So x plus 2 times 3x plus 2. The GCFs became a group of their own, and the common group comes down for the ride. Solve with the zero product property. X could equal negative 2, or opposite of this guy over that guy, negative 2/3. Solving quadratics by Frowny Face Factoring. Now, I know I'm moving kind of fast. I'm not recording this in class because I didn't want to make this video an hour long. So please pause the video as these steps go by if I'm going too fast. But you seriously have to talk yourself through it. Every step that I'm doing, it's not like you say it out loud, but you got to do it in your head. Is it ready to run? Yes. Why am I even Frowny Face Factoring? Because that number right there is not a 1. Wasn't it so nice when it was a 1? This is not fun, very frowny face. So we will make the frowny face and get you a number there. Negative 6. Right, we had to multiply those together. Find two numbers that multiply together to be negative 6 and add together to be negative 5. So 1 and 6, but one of them is negative. And it looks like that's my bingo right there. So now break him up into 4 terms. Lead off man, 2x squared. These two numbers should come next. Notice this. I'm going to go minus 6x plus 1x due to the fact that I totally wanted that third guy to be positive. Why? So I don't have to factor out a negative GCF. That's why I want him to be positive. So if possible, and then caboose equals 0. A lot of people get this far as rookies, and they're like, I don't know what to do next. 1, look it up on the sheet to help us out. 2, we just got to start talking ourselves through it. Ask for help, but it's double group. Boom, 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 boom. Now, take the GCF out of each group. So a 2 can come out, and an X. And then what we're left with right here is going to be X minus 3, right? Are we okay with that? And now here's a very weird situation for a new person is, okay, I'm down with the fact that I got to take out a positive GCF, right? But like between the 1 and the 3, I know it's negative, but between the 1 and the 3, 1 is the biggest number that goes in with that. X is right here. This guy doesn't have an X, so people go, there's not a GCF. And I do agree with you, but there is always a GCF. The GCF that came out is 1, right? So we have to factor a number out. And would you notice if I factored out a 1, I would get X minus 3. Remember, those are supposed to be the same. It already was an X minus 3, so that's kind of a cool little thing. It's like, oh, just got to take a 1 out. Because I need to regroup now. Red GCFs become a group of their own. Then the common group comes down for the ride, equaling 0. Solve for X. X could equal a negative 1/2 or 3. Holy macaroni, man. Weird, weird stuff. So let's try again. Got a frowny face. Need him ready to run, which he is. So boom, 18. I need to find two numbers that multiply together to be 18 and add together to be a 9. So 1 and 18, that's not working. 2 and 9, nope, those add up to be 11. 3 and 6. 3 and 6 is a bingo right there. So we will totally break him up into 4 terms. Lead off man. These two guys, it doesn't matter what order you're going to put them in. So I'm going to just go with that. And then caboose equals 0. Double group, man. So we'll take those two guys as a group and those two guys as a group. And then take the GCF out of each group. So a 3 and an N can come out. That would leave me with 3N plus 1, right? So I better get a 3N plus 1 again. Taking out a positive GCF, so between each one of those, I could take out a 2, right? And let's see if I get 3N plus 1 when I do that. 2N divided by excuse me, 6n divided by 2 is 3n, that's nice. 2 divided by 2 is 1, so yeah, equals 0. Regroup. 3n plus 2 is the GCFs, became a group of their own, and then 3n plus 1 equals 0. So using the zero product property, n could equal, almost put x there, but n could equal the opposite of this guy over that guy would be negative 2/3, or a negative 1/3 back in that guy. Nice. So here's our first one where it's not ready to run. Watch out. Got to get him ready to run. So 15n squared coming first, minus n second, and then to move that guy over, I need to have a minus 2. He is a positive 2. Needed to bring him over. I kind of just did a little flub right there. I didn't give myself enough room for a frowny face, you know, so it's weird. It's okay, but the frowny face should happen when you get him equal to 0. So multiplying those together, negative 30. Do you see how I had to scrunch all that in there? Maybe when we do the frowny face, we give ourselves room for the frowny face. So two numbers that multiply together be negative 30 and add together to be negative 1. 5 and 6, but the 6 is negative. Don't forget, if you're struggling finding these two numbers, I will help you. I'm just trying to make this video fast so it's not an hour long, but still slow enough that we can understand it. So let's break them up into 4 terms. Lead off man, 15n squared. Then I got a negative guy, so I'm going to do a minus 6n first, and then a plus 5n second, and then my caboose is a minus 2. And that equals 0 in this case. Double group. Boom, 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 boom. Take the GCF out of each group. So I can take a 3 and an n out. I'd be left with 5n minus 2. Yeah. And then I see this. I need to get a 5n minus 2 back. Hey, bro, he is a 5n minus 2. So that means the GCF you're taking out is a 1, right? Between a 2 and a 5, 1's the biggest number. This has an n, that doesn't have an n. And throwing them in parentheses, 5n minus 2 equals 0. Double group, 3n plus 1. In a group, 5n minus 2 equals 0 in that case. So then lastly, I need to use the zero product property. N could equal a negative 1/3 or a positive 2/5. And then here there's only 3 more, so I want to talk you through some weird things that could happen. So we'll do that here. Got it equal to 0, that's awesome. Got a frowny face because that's not a 1, so I'll draw my frowny face a little properly without a highlighter, and that's 24, right? These two numbers have to multiply together to be 24, but add together to be a negative, right? So that means both numbers are negative. So 1 and 24, both negative, nope. 2 and 12, if they were both negative, nope, those add up to be not negative 10. 3 and 8, if they were both negative, nope. 4 and 6, if they were both negative. There we go. Bingo, right? There's our two numbers. So now, here's the weird part that could possibly happen. When we split this up into 4 terms, everybody's going to have the same leadoff man, but it is very possible for you to write negative 4q minus 6q and somebody else to switch them around. Like what order these two go in truthfully doesn't matter, right? If you switch them around, here's what could happen. You and your friend could do everything different. You're going to have different work, but you will still get the same 2 groups back eventually, but they might be switched around. So you could totally do very different work than your neighbor, but man, you'll still get the same answer because it doesn't matter what happens here. So double group, and there's the tricky part. We're going to have to factor out a negative in that one also. So this will be a 4q coming out there, and then you'd be 2q minus 1, right? Yeah. Factoring out a negative here, And then you just look at them as positives and see what we get. There is a 3 that could come out, and I better get me a 2q minus 1 back when I do it, which I will. And now double group 4q minus 3 times 2q minus 1. So the GCFs become a group of their own. The common group comes down for the ride. Keep that equal 0 there. And q could equal 3/4 or 1/2. Holy cow. What I'd like you to do is try this guy. He's not ready to run, so I hope you get him ready to run. Remember, we got to keep it in the right order. And I'm going to give myself room for the frowny face. So the 12x squared is good. The plus x is good. And then I had to move that over, so I wanted him in the middle. And then the minus 1 is still good. So now let's see if you can do the frowny face part. So why don't you pause the video and see what you'll get. Alright, so I got to find two numbers that multiply together to be negative 12 and add together to be 1. Right? So those are negative 3 and 4. And then I want to split them up into 4 terms. Excuse me. I put the negative guy first. Double group. Boom. And then take the GCF out of each group. So in the first group, I got a GCF of 3x, and I got a 4x minus 1 left over. In the second group, it already was 4x minus 1, so I have a 1 left over in that case for a GCF. Then regroup. Those purple guys become a group of their own, and the common group comes down for the ride, and then use the zero product property to solve. Opposite of this guy over that guy would be negative 1/3, and opposite of this guy over that guy would be positive 1/4. So let's do one more, man. And the thing is, let's check, is he ready to run? Yes. And by the way, there is no GCF you could take out of these. Not going to happen. It's not a difference of squares. It's not a perfect square trinomial, and I can't easy factor it because this guy is not 1. So I need to frowny face factor. So one more time, please pause the video. We'll draw that frowny face, and I got a negative 18. Go through the process and talk yourself through it. So those two numbers were negative 2 and 9. Split them up into 4 terms. It's still, I think, nice to put this guy first and keep the third guy positive so I can take out a positive GCF. Double group, bada boom, and take the GCF out of each group. So in the first group, I took out a 2m, and then I'm left with a 3m minus 1. And in the second group, I took out a positive 3, and I was left with another 3m minus 1. Double group. You know, GCFs become a group of their own in red. The 3m minus 1 is the common group, comes down for the ride. Zero product property. So I've been talking you through this factoring cheat sheet for a while now. Here's what it'll look like. It is a test question. So the very first thing we do is we look for a GCF, right? So you'll just draw this little tree. It's got 2 branches on it because you're looking for a GCF first, but then your next decision is there 2 terms in this quadratic or is there 3 terms? If it's got 2 terms, there's only one thing we know that is. It could be a difference of squares. You don't need to write this down, but it's just like 4x squared minus 25. Like, isn't that a difference of squares? That's what we're looking for. But then over on 3 terms, the first thing we look for is if it was a perfect square trinomial. And if it was, we would factor it. But if it's not a perfect square trinomial, we then look to see if the a value was 1, to see if we could easy factor that guy. Because, man, that was a breeze, right? We didn't have to go through all this work. And then the worst case scenario is if there's 3 terms, we check to see if this guy can frowny face factor. And if it does, we go through it. By the way, next chapter, none of these things are going to work because not every quadratic equation is factorable. But so far this chapter, that's all we're rocking with. So please, 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 please let me know if you have any questions. I will be happy to help you. This is so much easier in person. Thank you so much for trying. Come on in and talk to me if you need some help.